All right, we're going to talk about statements and logic here. This is important because in geometry and in life, words matter, and you make certain statements and you want to be able to back them up, right, using logic, right? A conditional statement is a if then statement, so to be said. So some if some condition exists, then the result or the conclusion of that exists as well. So if your hypothesis is true, then your conclusion is also true. Okay? So if a figure has three sides, then it is a triangle. That is my P and my Q of my conditional statements, my hypothesis and my conclusion. Okay? A hypothesis is a statement that is not yet proven. Okay? It is the part, it's actually, this should be underlined with a blue line. Right? The hypothesis is the P part. Hypothesis has a P in it. Okay? And then the Q part is the conclusion that is made if the hypothesis is true. Okay? So a counterexample proves a statement false. Okay, it proves my hypothesis false. So read this carefully, and at face value, it looks like, yeah, this is obvious truth, but words matter. Okay, a square has four sides. So this is my counterexample, right? If a square has four sides, then it also has three sides, right? It doesn't say it had to only be three sides. It just says it has three sides. A square has three sides. In fact, it has four sides, right? So my counterexample disproved this hypothesis. However, I can add some more specificity to my P statement and add the word exactly to the P statement. And if I do that, if a figure has exactly three sides, then it is a triangle. And that is, therefore, that it becomes a true statement. Okay? I think that's all I really wanted to cover for this one, for statements and logic, but we're going to go into more details of this in the next video.